Hello there, Hydrauliac here. As a hydraulic engineer, I am always thinking about pressure drop. I consider pressure drop when doing system level design, when sizing individual components, and even when troubleshooting. Pressure drop is critically important to the function of hydraulics, but it is also one of the least understood concepts. Before we can begin to understand pressure drop, we first need to understand where pressure comes from. If oil is flowing through a pipe this size, it is going to take a certain amount of force to push the oil through. However, if I restrict the pipe like this, it now takes more force to push that same amount of oil through the pipe. Pressure is just force applied to an area, so this additional force shows itself as higher pressure. It is important to remember where this additional force comes from. This higher pressure means the pump will have to push harder to achieve the same flow rate. If the pressure requirement is too high, the pump and whatever is driving it can stall. If you are familiar with electronics, pressure drop can be compared to voltage drop. In both cases, the drop results from energy being transferred from one form to another. Just as a voltage drop across a small LED light in a flashlight creates light, a pressure drop across a hydraulic motor turns the drive shaft. Let's take a closer look at this motor example. A certain amount of energy is required to rotate this hydraulic motor. Here on the other side, I have an electric motor driving the pump. The electric motor is converting electrical energy into mechanical energy in the form of a rotating shaft. The pump transfers this mechanical energy into flow and pressure, or in other words, a combination of kinetic and potential energy. Once the oil reaches the motor, the pressure or potential energy is converted back into mechanical energy in the form of the spinning drive shaft. This energy is no longer in the hydraulic system and results in a lower pressure after the motor. This pressure difference is commonly known as pressure drop. This pressure drop is required for a hydraulic system to do any kind of work. If you've made it this far through the video, you've put up with a whole lot of science condensed into a very short time period. But we just have one more really important concept of pressure drop to go over. You may have heard the saying that oil will take the path of least resistance. This is the same as any kind of fluid, both liquid and gaseous. A fluid at a higher pressure will always try to move to the place of a lower pressure. I'll say that again because it's so important. A fluid at a higher pressure will always try to move to the place of a lower pressure. For example, if you blow up a balloon, it creates a higher pressure inside the balloon than out. So when you pop the balloon and give the fluid inside a path to the lower pressure area outside the balloon, the fluid inside will rapidly leave the balloon. Hydraulic oil is the same way. To have oil flowing, it must be moving from a place of higher pressure to a place of lower pressure. Sometimes this difference in pressure is doing work, such as rotating a motor or extending a cylinder. However, some degree of pressure drop is required to have oil flowing at all. For this reason, you will see pressure drop across not just motors and cylinders, but hoses, piping, and valves as well. Pressure drop always results in some kind of energy transfer. If the pressure drop is not doing some kind of mechanical work such as driving a motor, it will result in heat. Heat is usually a negative thing in a hydraulic system, which is why avoiding too much pressure drop is a high concern of mine when I am designing systems. However, pressure drop is also a necessary part of hydraulics. Thanks for sticking with me until the end. If you'd like to show your support to the channel, please like and leave a comment. As always, thanks for watching.